So folks, in this presentation, let's understand what is ASIC parasitic extraction. So many times it so happens that be it a circuit designer or a layout design engineer, they would be building their circuits, making connections, and they would run a pre-layout and post-layout simulations. So, but they really wouldn't be understanding what exactly are these parasitics. Say a circuit designer would do a design, but then assuming that there would be certain resistances and capacitances when they are designing a circuit, or for that matter, when a layout designer does the layout using metals and devices and all, there would be some amount of delay involved. And the layout guy tends to do the layout based on whatever the designer's specifications on the circuit, whatever the instructions, tries to maintain the capacitance values and net resistance values and all of these things. So eventually, what happens is once the layout is done, you verify it for DRC and LVS and all of that. And when you do the parasitic extraction, that's when you actually get to know how good you have done the layout. That's for the circuit, for the layout designer point of view. But from the circuit designer point of view, he or she would get a reality check that, okay, this is how my design would perform based on the parasitics, when you design a circuit in a particular technology. Okay, so let's try and understand what exactly is this parasitic extraction, what is happening in the background. Okay, how are these resistances and capacitances calculated? Okay, is it just one type of extraction or there are multiple types of extractions? Okay, let's dig a deep into that. So let's go to the next slide and understand that. But before that, apart from the working professionals, like who are already working, even the students, for example, would get a better idea when you are being taught in the college or in the institutes or whatever. You would get a complete understanding of the whole flow and how exactly the parasitics are extracted. So one thing to note here is all these things are learned as a part and parcel of your career. Okay, you wouldn't be getting this kind of knowledge and information in one shot. This is a kind of extract of our experience and knowledge what we share during our whole course of careers. These kind of, you wouldn't get any course anywhere in the market trying to give you the idea of what exactly happens in the background. So it's really worth it to understand what exactly happens in parasitic extraction. It's not just clicking the buttons here, but there's a lot which goes in the background. So let's go to the next slide and try and understand what we would be learning in this session. Okay, so the agenda of this whole parasitic extraction related, course or the whole presentation would be, let's understand what is parasitic extraction. Okay, what is this RC effect or RCC effect, what we talk about? Okay, and why is parasitic extraction needed? Okay, what is the importance of this? Why is it so necessary that one has to run the parasitic extraction to ensure the proper working of your design? Okay. One thing to keep in mind here is probably you may have come across these equations, R is equal to rho L by A and C is equal to epsilon A by D. Okay, A by D. So now these two equations you may have studied in your engineering. Okay, and even while working, even now we still use these equations. So to calculate resistance, we do that, and capacitance, and we get the sheet resistance from the design rule manual, and that's how we calculate the resistance and capacitances. So these are the two very important equations which you may have learned in your engineering, but you still use them in your actual work. Okay, so let me just clear the ink. And likewise, you've got flows for the analog design or the digital design. Even parasitic extraction has its own flow. There is a step-by-step process which goes in doing a parasitic extraction. Let's study about that. There are some prerequisites which needs to be maintained before taking the design to parasitic extraction flow. There are some steps, some settings which needs to be done when you're running a parasitic extraction flow. So how each and every setting impacts your design is what we will try to understand. The whole process as well. So the different kinds of extractions. So generally we go for resistance only extraction, capacitance only extractions, or RC, resistance and capacitance, or resistance and coupling capacitance extraction. We even have XL, that is the inductance extraction as well. So but for this section, we will just stick on to RC, RNC kind of extractions. So let's try and understand what are parasitic models, you know, and even how it helps in you in collecting or getting the accurate database. You know, it's not just clicking the buttons and saying that say for a layout guy, if your designer says, okay, give me a RC extraction or a RCC extraction, you would just go to the GUI, just give inputs and click some options and click OK. You get a .dspf file. You know, that's the name of the file, parasitic extracted file. So it's not just that, there is a lot more going on in the background. There's a lot of setting happening in the background. Okay, that we will try to understand in this session. So in some scenarios, you will have to do a selective net parasitic extraction. So what is that? We'll try and understand. Okay. And many times it so happens that for a larger design, if you want to run a parasitic extraction, the file size would go in GBs, tens of GBs. So it becomes very difficult for the simulator engine to handle such a huge text file. DSPF is a .dspf, that is a detailed standard parasitic extraction format. This is the file what we dump after we do the parasitic extraction. This is for, I'm mainly mentioning about the analog designs over here. Likewise, for digital, we've got SPF, and for, you would again process it and convert it into SDF as well. Okay, so here what goes inside netlist reduction? What are the pros and cons of going for netlist reduction technique, such that this is a trade-off what we tend to do, so that you should be able to simulate your design. You'd be reducing the size of your parasitic netlist. So reduction means you're losing some data. You're losing some values of your resistors and capacitors to reduce the file. How it impacts and how it is done, okay, we'll see that in this process. So you may have done the design fill, after you do your DRC, LVS, all the cleaning stuff, EMIR, in the end you would do the fill. So how does the fill impact the parasitic extraction? Let's have a look into that as well. So there's this concept of black box extraction and gray box extraction. So let's try and understand in this session. So what exactly is black box, and what is the change that would happen in your parasitic extracted netlist when you do the setting for a gray box? It would very hugely impact your parasitic extracted file. And along with that, you would have different types of extractions. So you would have a flat extraction, you would have a gate level extraction, you would have a hierarchical extraction, you would have a hybrid extraction, you would got mixed mode extraction, okay, and ADMS extraction, probably, So what I'm trying to convey here is, for different kinds of designs, for different kinds of modules, you have a specific type of parasitic extraction to be done. Okay, so now with all of this explanation of the agenda, which you are going to learn in this, so you might have got an idea and a kind of rough understanding that there is a lot more what goes into parasitic extraction. And let's study in this session. So we'll stop this session here and let's move to the next video to understand further.